This is 3.3 part 1, analyzing the second derivative. So we're going to be looking at what the second derivative tells us about the graph of a function. The second derivative deals with something called concavity. And concavity, if this is the graph of the function, is basically the shape of it. So if it's concave up, it's kind of be kind of a U shape, and concave down, it's kind of a upside down U shape, I guess. And what that deals with as far as a tangent line is if it's concave up, any tangent line that I try to draw, the graph is going to be above it. So I drew kind of a couple of different tangent lines, and you can see that the graph is always above any tangent line that you attempt to draw. For concave down, it's kind of the opposite. The graph is going to be below any tangent line. So if you kind of move your pencil or your pen on the graph, it's underneath it. Alright, so let's look at an example. So here's a graph of a function, and I want to state the intervals of concavity. So without making this too difficult, you're just looking at basically when the shape of the graph is down, and when the shape of the graph is up. Concave down would be from negative infinity until about 1. So we're going to say that 1 is kind of like a transitional point between concave down and concave up. So concave down is x is any value, any element from negative infinity to positive 1. And then concave up, again, is a transitional point from 1 to infinity. X, again, could be any value between 1 and positive infinity. Now, how the second derivative plays into effect is as follows. If you have a positive second derivative, your function is going to be concave up on the interval. Again, we're talking about certain x values from here to here, let's say. And concave down is if your second derivative is negative on a set interval from like negative infinity to 1 or 1 to infinity, whatever interval you find. And going back to this example, where this is switching concavity from concave up to concave down, that transitional point does have a specific name. That's called a point of inflection. So a point of inflection is whenever the graph or the second derivative switches concavity from either concave up or concave down, and vice versa. So this example, the point of inflection would be at x equal to 1. And let's look at an example with an actual equation. So I want to find the intervals of concavity and find the inflection points. Since function-wise my concavity is based on the second derivative, I have to go and find the second derivative to this. So finding the first derivative is just going to be the application of the power rule. It's 4x to the third minus 12x squared. One more derivative after that, again, is the power rule. It's going to be 12x squared minus 24x. Since I'm looking for the intervals on which it's either positive or negative, I kind of do the same operation sort of when I was doing increasing and decreasing, where I have to find the sign analysis. I have to find the intervals where it's positive and where it's negative. But I'm doing it with the second derivative. So what I first do is set it equal to 0. And I see I can factor out a common term of 12x. What I'm left over with is x minus 2. And then I set each factor equal to 0. So my values are going to be x equal to 0 and x equal to positive 2. So I need to now analyze the sign of the second derivative. So second derivative sign analysis. So I put these points on a little number line. And now I want to plug in values into the second derivative that's before each one of these points. So for example, I would plug in f double prime of negative 1, f double prime of positive 1, f double prime of 3. And again, all I'm looking for is whether this is positive or negative. Now if I plug in negative 1 into here, it's going to be a negative value. This is going to be also a negative value. Two negative values multiplied give me a positive answer. So I have a positive second derivative in this interval. If I have a 1 plugged in here, it's going to be positive times the negative, which is negative. And if I plug in 3, it's going to be positive and positive. So this is going to be positive. Alright. And so I can kind of conclude that my intervals of concavity, it's going to be a concave up from negative infinity till 0, and then 2 to infinity, and then concave down from x equal to 0 and 2. Now, as far as finding a point of inflection, this is a concavity change at 0 and 2. That's going to be a point of inflection. But then the point of inflection relates back to the function. So what I have to do to find my y-coordinate is plug these values back into f. So f of 0, when I plug it back into the function, it's going to be 0. If I plug in now 2, it's going to be 2 squared minus 4 times 2 to the third. Sorry, not 2 squared. 2 to the fourth. I'm sorry. So 2 to the fourth is going to be 16. This is going to be 4 times 3. Sorry, 4 times 8. I got 3 from 4 times 8. It's going to be 16 minus 32, which is equal to negative 16. So my point of inflections are going to be at the point 0, 0 and 2, negative 16. Alright. I'll go ahead and give you guys a little U-try problem. So on your own, see if you guys could determine the intervals of concavity, find the point of inflection. So at this time you should probably pause it, give yourself a chance to try it, and in a moment I'll push up the paper and show the answers. Alright, so at this point you should have already tried this, and here is what I got. Second derivative is just going to be a sine. Set that equal to 0, and you're looking for when sine is equal to 0, so you do the arc sine of 0, and sine is equal to 0 at pi. I can't include 0 or 2 pi because that's outside of the interval. I don't include the endpoints, so it's only equal to 0 at pi. So then you pick a number into the second derivative that's to the left of it and to the right of it, and I got positive and negative. So it's concave up from 0 to pi and concave down from pi to 2 pi. And then the point of inflection, if we plug in a pi into this, sine of pi is going to be 0, and then 1/2 times pi is just pi over 2. So I can check this tomorrow. I can clarify if you have any questions as far as, this should have been 2 pi, as far as the second derivative analysis and all that. And that's it.